Hello everyone and welcome back to Mix KOTTU. I am Chamoda Gunatilakar. Today we are embarking on an exciting journey into the world of electric motors, specifically brushless DC motors or BLDC motors. These remarkable devices are at the forefront of modern technology, and I am thrilled to be your guide on this adventure. So, stay tuned and don't forget to like, subscribe, and hit on that notification bell so you won't miss any of our exciting presentation here on MixCode2. Let's unlock of the power of brushless DC motors together. Throughout this journey, we will dive deep into the inner working of BLDC motors, explore the differences between brushed and brushless design, uncover the advantages and disadvantages of going brushless, unravel the science behind their operation, and discover their wide range in application across various sectors. Now, what makes BLDC motors so remarkable? Well, they mark revolutionary departure from the conventional DC motors that have been around for much of the last century. The innovation lies in the way these motors are commutated, not mechanically with brushes but electronically. To appreciate the significance of BLDC motors, it is essential to acknowledge the historical backdrop. It wasn't until the 1960s, with the development of semiconductor electronics, that the possibility of these motors began to unfold. This development was a game changer, paving the way for more efficient, reliable, and versatile electric motors. Let's talk about the difference between BLDC motors and brushed DC motors. So there are some table about differences between BLDC motor and brushed DC motors and actual advantages that we can gain. So electronic communication based on topological information and mechanical brushes. The commutation feature, in BLDC motors we used electronic commutation. In brush DC motor we use mechanical brushes. So there is no brush. The efficiency is very high in BLDC motor, and brush DC motor it can be moderate. So maintain little because there's no brushes. So there's no any thermal effectiveness. So there's no spark. We can talk about later. So just a little reminder, there can be a spark generate in the motor because of the brush. So there's no brush, there's no spark. So maintenance is very low in the BLDC motors. So thermal performance is better because I said that before. There is no any brushes. The thermal performance is better. Output power is high, electric noise is low because of there is no any brush. Lifetime is low because there is no any brush. So next one is advantages. Actual advantages that we can gain from this BLDC motor. The BLDC motor is electronically commutated by power switches instead of brushes. Compared with the brush DC motor or an induction motor, the BLDC motor has many advantages. Here see, this is brushed DC motor, so there is a spark. You can see in here and here there is a spark. That spark causes thermal effects in the motor. So it may reduced by without brushes in BLDC motors. So high efficiency and reliability, lower acoustic noises, smaller and lighter, greater dynamic response, better speed versus torque characteristic, higher speed range and longer life. These are the advantages we can obtain from these BLDC motors. So let's see about working principle of this BLDC motor. Working principle of DC motor. Before we discuss about BLDC, let's talk about the DC motor. So we all know about the coil between the permanent magnet. So this coil has some current. We gave a voltage between these terminals, and there are some current. So because of this current, this coil is become a magnet between two polarities, this coil going to be rotate. This conductor part have F force to upward. This conductor have F force to downward. Because of that, this coil going to rotate. We can find rotational direction from left hand rule. So, to maintain the rotation, current direction must be continuously reversed. So, here this direction is reversed when the light blue part come to here. Now it's in negative side. After here, it's in positive side. So the force direction is going to change. Is continuously rotating because of this commutator. So here is the DC motor, DC brushed motor. So there's a three coils and give a current. See, in blue color there's a south pole and red color is a north pole. Now like this, red color coil is attract to the south pole. Blue color south pole attract to the north pole. Now it's repulsed from the south pole and attract to the north pole. Likewise, it's a loop. Blue to red, blue to red. It's blue now red. So this is a two status because of its give stationary magnetic field, and this is a rotor which is rotating, and there's a commutator and the coils and the brushes. Let's see about commutator and brushes. The commutator and brushes are distinctive features of brushed DC motors. Fixed brushes provide electrical energy to the rotating commutator. As the commutator turns, it continuously changes the current direction, reversing coil polarities for ongoing rotation. So here, reversing coil polarities always. Working principle of BLDC motor. So this is a outer runner BLDC motor because this outer shell is rotating and the inner shell is stationary. This outer shell is a permanent magnet and you can see the inner shell. We can call the stator is a bunch of coils. The outer shell and we can call it rotor. So as their name implies, brushless DC motor do not use brushes. With brushed motors, the brushes deliver current through the commutator into the coils on the rotor. So how does the brushless motor pass current to the rotor coils? It doesn't, because the coils are not located on the rotor. Here, coils are not located on the rotor. The permanent magnet is rotating. The coils are stationary. Instead, the rotor is a permanent magnet. The coils do not rotate, but are instead fixed in the place on the stator. Because the coils do not move, there is no need for brushes and commutators. Coils are never rotating, so there is no need of brushes. So let's find out the working principle deeply. Okay, this is a outer runner BLDC motor. We can say this is a B, C, and same pair A, B, and C. Let's think this is a N pole and south pole, the permanent magnet. This permanent magnet is rotating. Now we give this voltage source to the this B coils like this. Current go to this side, current goes to this side. So this becomes south pole, this becomes north pole. Electromagnetic south pole and north pole. So this permanent magnet north pole is attract to this south pole. This permanent magnet south pole attract to this electromagnet north pole. So it rotate to this direction, rotate to this direction. Now we plug these terminals into C coil. It also like this, the C coil edge becomes south pole, this become north pole. This permanent magnet uh, pole attract to this electromagnet north pole. This permanent magnet north pole attract to this electromagnet south pole. Likewise, it's like to A, it's like to B, just like that. We can energize this each coil and this permanent magnet attract to each coil. I point out some hilarious thing. It's like a donkey attract to a carrot. This permanent magnet looks like a donkey and this carrot looks like an electromagnet. This permanent magnet uh, attract to the electromagnet and it goes to another coil. It's when we energize another coil, that permanent magnet also attract to that coil. Energize this B coil, it's behave as an electromagnet south pole. If we energize this coil, this C showed like a south pole. This permanent magnet attract to this C south pole. And again, this can be south pole. Again, south pole attract, south pole attract. This north pole attract, but it's never reached because this south pole is hopping to each coil. South pole, south pole, south pole. This I taken this part only, not taking this part. It's also correct. So south pole north to south pole north to. It's become north, south, north, south, north, south. So this is the basic working principle of BLDC motor. So we can found when we energized a single pair of coils, there are still two coils are not energizing. So that is a huge power loss. When we energizing this B coil, A and C aren't energizing. That's causing huge power loss. That's why we construct this BLDC motor in a special manner while using a conductor connecting each coil that we call push-pull operation. When the uh, B become a south pole, this A become north pole. So north pole repulsive. This north pole is rotate to this side, not attract to this side, is push. And this B become south pole, this north pole is pull. Likewise, push-pull operation. So we energizing A coil and B coil. So this slide shows how this the BLDC motor works when the uh, two coils are energizing. See, this A and B energizing and C is not. B and C is energizing, A is not. And A is negatively energizing, C is energizing and B is not. Let's see what is negatively energizing and positively energizing in deeply and about this graph. So this rotor rotating in this direction and we can say this is A, B and C. So let's assume we give 10-volt voltage source to A and B and we energizing A and B coils. So A and B coils are when energizing. This is a permanent magnet in the north pole. This is permanent magnet of south pole. So this north pole is attract to this electromagnet south pole that which is built in this A coil. In meantime, this B coil is energizing and other side of the B coil is north pole. This permanent magnet north pole is repulsed to this north pole. So it push and the south pole is pull this permanent magnet north pole. Okay, like that we can say B is A is off and B is on and C is on. Okay, like that. We can say B is off, C is on, and what happened to A? Now this north pole is not in here. This is position 1. This is position 1. This is position 1. This is position 1. Right? This north pole now in here. Now, now in here. This is position 2. This is position 2. Because this south pole attract this north pole, and this C is energized and it becomes north pole. So it push this, it because it's repulsive, it push to B. This is second position. Then it become here. Then it came to here, the north pole. Now it is position 3. 3. C is energized. C have electromagnetic south pole, so north pole is attractive. Now what happened to A? This is, if this is north, there is a south in here. South. So in A, what happened to A? A becomes south and it pushed the south pole to this direction. That's why we call it have negative voltage, because it changed the direction not in the position 1, it's a new direction in position 3. In position 1, in here this is there have electromagnetic north pole. In here we have electromagnetic south pole. So that is a different position. So we can say it is a negative voltage site. Likewise, it's continue. It's become 0. It's continue to north and it's become down like this. Because why? The fourth position B is not like the first position B. First position B is like here. Here is a south electromagnetic south pole and electromagnetic north pole. In fourth position, here is a electromagnetic south pole, electromagnetic north pole. The poles are changing. When the electromagnetic is changing, we can say this voltage going to negative side. Okay, because the push-pull operation, we can save the energy, and also we can build the effectiveness of this BLDC motor using the push-pull operation. Here's the working principle of BLDC motor. Let's see the construction of the BLDC motor. We see this before. This is a outer runner BLDC motor. This is a in-runner BLDC motor, because this inside permanent magnet is rotating. Outside permanent magnet is rotating and inside permanent magnet is rotating. Here the difference between brushed DC motor and brushless DC motor. Okay, there is brushes in here and here. There's no brushes. This is a outer runner. Now this is a inner runner BLDC motor, because there is a permanent magnet inside the BLDC motor. This is a stator and this is a rotor. We explain how we energize this each coil, but how we construct it, how we energized coils time to time. Sometimes it's A or B and B or C, and it's converted to B and C, A and C. How it move, how it energized in different time. For in that we using sensors. That's why we said this BLDC motors built after the semiconductor generation, because building sensors we need transistors. Using these transistors, these transistors and using as a switches. While using these transistors, we can build a sensor to allocate time which coil must be energized. Which coil at which time. It decided by the sensor. So, with a BLDC motor, power transistor technology, we can use to build these sensors. We can make the coil stationary and artificially switch the direction and timing of current flowing through them. We can switch which time, I said before that, which time, which coil, that controlled by the sensors. So it is a huge improvement of the uh, DC motors by using sensors, and it became brushless DC motor. So here which I show that I said before, connecting each coil by using a conductor. There is a huge power loss when we energizing a single coil. So we can energizing a two coil at a time, we can save more power. For that, we using a conductor to save the power. In here, we demonstrate that using a one conductor. Here, this is a conductor connecting this coil to this to this conductor using to connect each coils. This is the construction of a BLC motor, and let's move to the type of BLDC motors and applications. We said it before, and I said before. We discussed about this before. There is a inner runner BLDC and outer runner BLDC. Because this permanent magnet is rotating in outer shell, this permanent magnet is rotating in inner shell. That's why we called it this is a inner runner BLDC, and that's why we called this is a outer runner BLDC. So we can discuss about applications by using these BLDC motors. We have seen that BLDC motors offer high efficiency and electromobility, and that they have a long operating life. We already know that we are not using brushes, so we have longer life. They are widely used in devices that run continuously. So there is no spark, so there is a long life. So that's why we use BLDC motors to having continuously running operations. They have long been used in washing machine, air conditioners, and other consumer electronics, and more recently they are appearing in fans where their high efficiency has contributed to a significant reduction in power consumption. So they are also being used to drive vacuum machines. In one case, a charge in the control program resulted in a large jump in rotational speed. As an example of an superlative controllability offered by these motors. Basically, we can discuss about the fans and washing machine, other electric devices that using in long time and running continuously. BLDC motors are also being used to spin hard disk drives, where their durability keeps the drives operating dependably over the long term, while their power efficiency contributes to energy reduction in an area where it's become increasingly important. We have uncovered the inner working of these remarkable motors. We'll delve into the difference between brushed and brushless design and appreciated the advantages and disadvantages of going brushless. We have seen how they are propelling innovation across various industries and driving energy efficiency to new heights. Your interest and engagements are what fuel this presentation, and I'm genuinely appreciative of your time and attention. Your questions, comments, and discussions are what make your community thrive. If you have any further questions or if there are any specific topics you had like to us to explore in future presentations, please don't hesitate to let us know in the comment section below. So, and finally, before we part ways today, I invite you to subscribe to the KOTTU channel and hit that notification bell so you won't miss any of our upcoming presentations. We have a world of fascinating topics to explore together, and I can't wait to dive into them with you. Once again, thank you for being a part of the KOTTU community. I look forward to our continued journey of learning, discovery, and innovation. Until next time, stay curious and keep exploring. Goodbye for now and take care.